Alrighty there. All right, I'm gonna use my computer again because I forgot my tablet upstairs. Or I just purposely left it because I was too lazy. But I haven't finished this yet. I am doing that right now. I'm actually gonna show you the process of doing this, uh, just because I thought it would be fun. But before we do that, back to good old pain. That's not really that painful. Since I don't have my tablet, I'm just going to explain it out loud with words and see how far I can explain it. So the first one we left off, oh yeah, I added answers may vary because all of these I realized the answers will vary a lot. So yes, so we're doing this one if I remember correctly. So first of all, this is a famous the kite problem, and I just labeled it kite theorem because why not? I remember someone saying that looks someone said to me that's what a kite looks like. So that's I don't remember who did that, but yeah. So there's many different versions of this. So I couldn't quite remember what kind, but I just said, all right, I'll just dump these two and hopefully that's good enough for all of you guys. It's kind of dark in here. Let me actually turn on the lights. Turn on my second light. Okay, I hope that is better. I think that was. All right. Anyways, the first thing we know is that in a kite, we have E is the midpoint of BD and AC. Can you look at my uh? Can you see my Actually, why am I saying it? No one's listening, so I have to actually figure out myself. I don't think anyone can see my I don't think there's the ability for me to do a laser. Okay, so then I'll do the other way. So by my mouse, it might be a little bit wobbly. This is BD, and then that's the midpoint over here, and that's where. And then there's no midpoint in AC. What the hell am I doing here? So over here, I already made a mistake, and AC should not be there. I just realized. And I kind of like that format, so I'm just gonna do a space over there. Anyways, so I got it wrong again. So who the fuck did? Yeah, I do make a lot of mistakes. All right, E is the midpoint of BD. That's true for now. Anyways, next is CD, which is let me give me my annotation wand. CD should be equal to BC by isosceles. Basically, if you want to check it out, if these two are equal and this is a triangle, then we know that these angles must be true. It's an if-then statement if you want to do that. I don't do that because I don't see a need to do that here. I should have done that. If you want to do it, you can. And actually, that's one way to actually solve this. That's why the answer may vary. That is one way you can do. Oh, Control Z. Oh, actually, doing it by mouse is actually easier. Once you because I already typed everything. All right. BC and BD, and then there's this one over here that will give you another isosceles triangle, which means this angle must be the same too. I'm not sure if I used it. I don't think I did, but from this. And then if you want to label it, you use something like this. Yeah. The reason I didn't do that by my sketch was because it was really painful for me to make the lines like exactly the same. So I just said, I'm not doing that yet. If I have ever get the time to do it, I will. Um, which means never. Anyway, next thing, CA is equal to itself. You're just claiming this. Why you claim that? SSS then. These are two triangles are the same. Basically saying that this triangle over here and this triangle over here is exactly congruent, which means it's exactly the same. So now you can call upon a lot of things over here, like, this thing, I can never say it correctly, which basically guarantees that ABC, so this angle over here, is the same as, oh yeah, this is for this thing over here, CDC over here, which is necessary to solve my first portion of the proof. Anyway, there's a second one over here, which is BAC. I know this is necessary for the other one. And over here is a CAD over here, if I remember correctly. Yes. And then substitution property because I claimed it to be this, but I needed to claim over here with the E. So I just use substitution property because they're the same thing. Um, and then we went to SAS because we know this angle. And earlier I claimed this one too over here. If you look over here, I put another reflexive property earlier. And like this, so these triangles must be the same, which means they're congruent, which means over here you'll find out by the last theorem, if two lines are congruent, adjacent angles, and the line is perpendicular, is because it means that this is this and this is congruent. Well, what angle can give you that? That's 90. So that's basically no duh. And um and over here I said that over here. Where is it? No duh. But that's true. I forgot to add that. Just if you realize that I just added that. Yes, I just added that because I forgot. Anyways, as you can see, now we're going to the painful part with circles. Um, yes, these earlier wasn't painful enough. It wasn't really painful at all, actually. But um, chord, secant, and tangent in a circle. I know that in trig that you have different definitions, but for a circle, we have this definition for tangent, this definition for segment, and this definition for chord. Okay, so honestly, why is this tangent like this? Why is it? And I'll explain to you right now kind of how tangent works. Any function over here, if you draw a function like this, the tangent is on the line, usually. If it's not, if it's a plane, it's different. A plane will give you a plane, but plane that's tangent, but it basically makes a linear line on a function or any equation. So if this circle, this line is the equation, then it makes sense that the tangent will be across over here and always do 90 degrees like this. That's basically what's happening. Now I realize I probably need to do something is similar to this section over here, where I put down what secant tangent by definition because I really didn't do definition what they mean over here, like 1, 2, 3, 4, 5. Like I'll do it right now actually. I didn't think about it. So I already explained it here, so why don't we make it brief? Chord, um, it a segment that is inside a circle and touching the edges and not intersecting. So like touching, okay, fine. Touching the edges. Okay, and then secant, exactly the same wording, but instead of touching is intersecting. And then tangent is a linear line parallel to the edge of a circle. I need to do something really quickly because I have to say chord and circle because I don't remember about the chord, but I know for secant, there's a more interesting definition for secant that goes beyond this thing. I have to double check if this actually does the same. I'll check later. Now that does that ruin things? Yes, it does. Okay, fair enough. I was expecting that. We'll just increase this one so that this one makes it a little bit cleaner like that. And then it looks fine. All right, good. It looks fine. All right, so next area of a circle, oh, not area of a circle, we have to do another state reason proof. This is a simple one. Um, I I'm just showing that it's possible to use statement proof reasoning. I don't really like to use statement reasoning for a circle. It's just because of pain a little bit. Um, but you'll see O is usually used as the center of a circle in my geometry class. Later on, I have used A, B, C, any letter, but back in geometry, I always use O for some reason. Excuse me. OM is perpendicular like this, and you can kind of see it's HL, and then you get AN and BN. I'm pretty sure this is the same theorem as the kite theorem, just rehashed a little bit. Um, And then we finally get to here. I did not explain what a pi is. Pi is actually the diameter divided by, I believe the diameter divided by circumference, right? No, circumference divided by diameter is pi. Um, yes. But you can also get pi another way in calculus, which is interesting. Uh, I forgot, but I did it a long time ago in one of these things. I'll explain later. I think it was some kind of prove a circle or something, prove how to get pi or something. I don't remember. Uh, you'll learn it later, I guess, when I get there, because it'll take forever. Anyways, here's the interesting part. We get area, we get circumference, and we finally get into circle, and then this is gonna be interesting. Central angle. An angle formed the center of the circle. Now we're gonna see arc of a circle. Arc is not arc length, to be clear. So arc is basically the central angle if you think about it, but it's not an angle. So the way we're going to define it is arc is the curve. The curved part of a circle, the unit are the geometric shape basically. Does that even make sense? Probably not. It took a while for it to make sense in my head, until I realized that it's a dimensionless unit that quantifies how much uh oomph we went, how much this thing is, like a turn like this. Like that's the oomph over here. Um that's kind of how I could describe it. Um to be honest with you, in my engineering classes I've never used it. But I definitely used arc length before. Arc length is useful. It's the radius multiplied by the angle in radians. By the way, arc is always in the always unitless, and you'll find out you have to use degree always for some reason. And I'm baffled why it's. I mean, it's useful. I can see why it's used, but it always confused me why it's used. And it works. I guess what I'm saying is this looks weird, but it works. Okay? Now, as you can see, uh, if you find a central angle, you find the arc length of something. Or no, not arc length, arc of something. Arc length requires the angle times a radius, so it takes a little bit more for the arc length. And arc length is way more important in my mechanics, dynamics things. Um, Now, fun fact, any triangle can be captured in a circle. Anyways, here's where we start another thing. So we're gonna say A and B and C and B or BC when now we're going to form a kite with this. Over here we have a kite over here, and from that you can always figure out that. All right, first of all, we're gonna have to explain a little bit more. B, oh, I already got it wrong. BAC over here like this, and then over here like this is gonna be solvable. They're gonna be the same because these are isosceles. ABCD isosceles. Anyways, and how do you figure out isosceles? Well, you can actually do a proof, but I'm not gonna. But basically, this is 90. This is 90. This is gonna be the same angle because we have chose tangent. Um, and then you can figure out that this is a bisector, and then you can figure out a lot of things. But yeah, But anyways, you could do one of those darn tables, but I'm not doing it because I'm too lazy to do that. It'll take forever. Um, if I'll be honest, if I need more like geometry proofs, I will do all that stuff. But I just want to go to calculus because where all the fun stuff are usually. I'm kind of rushing to do this a little bit, aren't I? Because otherwise, I think I'm gonna be here for 10 years. Um. BAC over here, BAC, and then this, and then we figure out this 180 is total triangle. So any triangle equals 180, and then we minus 90 over here. Where does that 90 come from? Over here. This is all 90 degrees. So we get minus 90 over here. And then, oh, where does that y minus 2 come from? Well, we divide it by a bisector over here. If you actually do the proof, you'll figure out that one of the proofs you can do is that this is a bisector. By congruency. And then this is y divided by 2y divided by 2. And if you simplify that, it's 90 y minus y divided by 2. Next, we figure out over here that since we figure out this is 90 minus y divided by 2, we can subtract 90 to it. Yeah, to get over here y divided by 2. Now, this might look familiar. If you did it early, if you were here earlier, you would realize that this triangle is similar to this triangle over here. And we did this many times, and you could have gotten it that way too, honestly. And I'm just showing you another proof way to do it. But yeah, you could have gotten that, and you can just, oh, that's instant. That's y divided by 2. But I'm proving it again. Did I prove it last time? I don't know. But I'm proving it now. Anyways, I think I did definitely prove it. Anyways, y divided by 2 plus 90 over here. Plus 90 comes from over here. And then plus this angle equals 180 again, which equals 90 minus y divided by 2. Now, with these two, these are like this form over here and this form over here. We have, if you add those two up, like we should, we get this format over here. So we now figure out what AC could possibly be with the y, which is 180 minus y. So if you want to shortcut it, you could have done 180 minus y equal AC. Yeah. And now X over here is 360 minus AC, and AC is this. Uh, ABC is the major. Oh, I forgot to write about major over here. Did I? I don't think I did. Okay, so major has to have three different letters because yeah, that's how they're denoted. Uh, denote by three letters. Note by three letters with arc on top. With two letters with arc on top. So that's why I made the fictional D over there. So if you have a proof there, you'll be asked to draw a D over there just because you need it. Anyways, from there, here's some algebraic shenanigans. Because so get this into this form, and with this form divide by a half, and then you realize you have 2AC, and then split into two, and you get 360 minus 8. And this is important because now you have a relationship of y with ADC and AC. Oh well, this is not really important in real life because you never use it in my opinion, but nevertheless, um well, that's the equation that's what's the word? Universal, like everyone teaches that, but no one teaches how to get there. Because I remember in my geometry class, they didn't teach me how to get there. They just gave me it, and I was just like, okay, I'm gonna have to figure this out later. I don't remember them going to my proof section over here. I remember them just going straight into this, and then I remember, okay, no, actually maybe he did, but I wasn't paying it. No, no, was it COVID year? No, it wasn't. Maybe there was a geometry. No, no, no. Those geometry proofs didn't do it algebraically. So no, no, no. We didn't prove it. And then I gave you one problem with it, and I realize now that I need to like darken this because I want the contrast. Now we're doing this problem. Now, so far I'm here. Oh, thank you. No, thank you to the deals. I'm not making any deals. Okay, here you go. This is more. All right. So what I was doing was I was given these two because I'm giving these arcs, which means autonomy, you're just basically giving me the angles in the central angle, basically, uh, given. And I said, okay, I can get this over here by this format because the line in 180 minus x is AOC, AOD. And then we could do 180 of again because the triangle, the angles, total angle of the triangle, if you add all up, it'll always equal that. And then you can say minus, oh, I forgot. Oh, oh, did I forget again? Yes, I did. Can you guess what I forgot? This is also supposed to be a minus, I think. Because you did 180 minus x. No, it's plus y because yeah, that's correct. And then this is y divided by 2 because okay, so basically I have this, I have this, I have this. I Now I'm gonna grab the other one over here. So we're gonna really quickly figure out what BCO is, and I wish I had water. I think I do. Right. And that was I'm dry from talking so long. Anyways, what was I about to do again? I don't remember. Oh, that water was a little bit stale. But anyways, I have to brush my teeth again. Anyways, where was I again? Over here is what we're going for. So we have all the necessary prep time, right? So we have, again, new equation. So what we're trying to get is x plus y a half equals ECD because that's the standard formation that I remember I wrote down that the teacher gave, sorry, in high school. So. That's what I'm gonna get. And then that's what I'm gonna give you guys. I don't know how to get it. I'm just trying ideas until I get it. That's basically all I've been doing. Like, all right, let's try it. 180 minus this. Okay, it's probably not gonna work, but we have more information this way. And then we basically have this, which is gonna be BCO. And then we can say the opposite is the same thing. So I can write it like BCB, OCB. It doesn't really matter. Now we have this format. I can simplify a little bit over here, but before we go, what can I get from this? So I already know from this that I know this already. So I can get uh I can get this format over here. I can get the uh arc of that, and I can also get the arc of this. If I really wanted to from this. But I don't want it. I want to get this angle. So I know I got this angle now. So what that tells me is I need to do 360 minus 2 of this angle divided by 2. Is that correct? Let's try it. Let me go and get my typing on or whatever. So basically what we're having is this times 2, so we can now please I need to simplify, man. I'm not having this bullshit on here. That sounds like unprofessional muck. of stupidity. Oh, minus. Oh, that sounds so wrong. I'll explain to you later, but it's supposed to be x plus y. That's why I'm trying to get that format here. I'm not getting x plus y here. Oh, all right, whatever. We'll figure that out later. This is 90 now. And then this 90, so this is all turned to 90. Okay. Okay. So 90 is over there. I'll screenshot it later. Um, Now we times it by 2 because we said that over here we need to get two of those and then so 360 multiplied by two of those angles. So we have 360 over here minus 90, 180, and then this is equal to angle DOE. Angle DOE. That should give me everything. Now, that does not look correct. Ooh, hmm. Okay. I have my work cut out for myself. Something's wrong. A car finish. Clear all drawing. Yeah, and this is where I go to double check mode and just keep on checking until I get the right answer. Last time it took an hour. I might have to cut things out. All right, so we have 90 plus. All right, so we have 90 plus. Okay, okay, okay. All right. Let me just think. Right. 180 minus x plus y. 180 plus x plus y divided by 2. That's correct, right? We're getting this angle and this angle, okay? 180 minus that, so we get AOD, that is correct. And then we get 180 minus x, which is from that, uh, plus y, yeah, plus y, equal what? Ah, something's fishy here. I think something's fishy in this slide over here. Ah, so this angle plus y. There it is. There is a mistake I made, right? No, no, that's right. That's right. No. And then we say, oh, here's the mistake I made. This over here. This is not correct because it's 180 again minus this angle over here, right? Okay. So that's wrong. So this is this over here. So what we need over here. Okay, let me get this. Try to get OBC, right? So first of all, we have 180 minus over here this stuff, right? So this turns to a plus and this turns to a minus. And then we get divided by 2 because that's necessary. And then this will then turn into x minus. Okay, that's interesting. I don't like it, but sure. Is there a way to get y as a minus? We'll figure that out if we can. Maybe I'm mistaken by the definition. It could be. So next is then we have minus. So we have minus plus. What's OCB? OCB, which is 180 minus this. Yeah, here's a mistake. So 180 is total. We minus that, but also minus y again. So minus y will give you a minus half over here, right? And why did I write this twice? I have no idea. Anyway, now we have this. And now, oh, we can actually write that twice. That's fine. I mean, we can just do minus over here, and we can make it a plus to make it easier. And then we have to make this twice. So this is closer. It's closer, not the right answer, but closer, definitely. What did I do wrong? So right now we're saying that OCB is solved, and we multiply that by 2 to get these two angles over here. So x plus y, excuse me, minus minus is this over here. Let me just bracket this for now. So that's what we have when we multiply that by 2. And then we do minus this. And then we do a divided minus this. So this is minus plus plus. We're getting closer. And then we divide everything by 2 to get your E. And in that equation, that is closer. That's closer. We're saying 180 x plus y. Now I have to get rid of 180 somehow. Because 180 is absolutely terribly fucking wrong. Where's OCB? OCB is over here. Okay. So we started with x, and 180 minus x is correct. 180 minus x plus y is correct. And then 180 again minus 180 plus x minus y. Did I make a mistake here? So this is OBC over here. This OBC is what I'm looking for. Okay. And then this is equal to ODC, which is 180. And what I did was minus by BOD, right? And I divided by 2. That sounds really correct. What could it possibly be? But for now, I don't know. Um, I don't know. What could possibly be wrong here? There's definitely a half. This looks correct without the 180. If I could get rid of the 180, I would say it's correct. But why is there a 180 here? Unless I forgot something. Wait a second. What happened here? This is supposed to be like this, isn't it? There you go. That's the mistake I made. That's the mistake I made. There you go. There you go. That's 0. And then we get it. We got it. Okay. Okay. Got it. There we go. Found the mistake. So I don't know why I got from 90 to 180 to 90. That was a mistake. Okay. And that's how all these geometry proofs go. I just think for a minute, like this, contemplating, and it said, "Oh, that's a mistake," and then I figured it out. It's a pain in the ass, honestly, which is why I don't share it with you guys. I mean, I'll share it now. I mean, why not? It's not that painful. Now I'm going to screenshot it and put it here. So now, where was I? OBD. Okay, so this portion is where I got it wrong. Okay, so we just need to like screenshot this portion. and then get rid of this part because I got that one wrong. And then we put this over here. Now, I know this is correct now, so I can actually just get rid of that for now. And then we can just move on to this. So this is X 180. If I have made an angle mistake, I will have to retype it, so that's gonna be a pain in the ass. That happened a few times. And I don't look forward to that. I know I probably made an angle mistake with the late time of the evening. It's like very late right now, so I'm very bound to make one or two or five or six mistakes right now. Do I want this one? I already did that one. Okay, so the next view is this. Then we're done. And then we're done. We're fucking done. Okay, I think we're good. There you go. And I can clean it up later, but so far I got the general. No, that's not good enough. I don't like it. I like this better, I think. The last section. I don't like that either. Hmm, there we go. Oh, there it is. Beautiful. Okay, that looks better. And then the last one over here, and we're done. So I made a big matter. Let me just delete the fluff. So we're done. All right, that took a longer time than I expected. All right, is that the only theorem? No, that's like one more theorem I'm thinking of that I have to like prove, which is gonna be a pain in the ass because I don't know how to prove it. I have to actually, I have the final version of it, um, but it has no proof, so I'm gonna have to prove it. Again, long, just it's just doing that, trying to figure out what the mistake I made, and then just adapting to it. Basically, is the whole entire process of doing this stuff. It's not bad. It's not horrible. Um, so the last one, I'm pretty sure. I mean, I might want to make one question of this too, like I did over here, and then move on to the last one. Remember the circle series and arcs, which is basically like this internal like this, and then we're gonna go to the triangle one where we have an internal triangle like this, and then we have a few others where we have something like this. Am I showing you anything? I'm not sure if my mouse shows. I was gonna explain like there's one like this showing up. Oh, what happened? Why is it not working? Uh oh, okay, it's not working. Okay. Anyways, there's a few things here. So that's one of them. The other one is I believe something like this, for to show like this works. The other one is something like this, this. Something like this. I don't remember, but I'm gonna have to prove that. And then there's one last one. What was the last one? I think it's something like this or something. Like versus this or something. I'll do it later, but yeah, there's a lot of circle ones I want to do. But anyways, clearly I've done, and that's pretty much all I have today. So just gonna stop recording, I think, and then